We're looking at congruence now, and we've been working with transformations, and the definition here of congruence is a two-dimensional figure is congruent to another two-dimensional figure if the second figure can be obtained from the first by a sequence of rotations, reflections, and translations. Given two congruent figures, describe a sequence that will exhibit the congruence between them. Well, we're going to start out with singular. In other words, we're only going to look at if these could be set or defined to be congruent by a single transformation of either a translation, reflection, rotation, and then if you want to go advanced, we'd look at coming up with combination techniques. We have the original in black labeled ABC, and the image is in red. So if these two are congruent, I should be able to come up with either a sequence of transformations to take the black onto the red, but here we're only looking at a single one of these and techniques to identify the single idea, whether it's a translation, reflection, or a single rotation. So we start the same, but I just want you to see that this is set up to be dynamic so that if we're not sure, we can move some points around to more clearly identify the image points. So we connect each point to its image point with a segment. As we look at those, there's two things that I think we should notice right away. One is that they are parallel. But that's not the only thing we should notice. We should notice that they're all of those segments are the same length. All right, so if we're not sure about that, I'm just going to show this a little bit dynamically. All of these seem to also be the same length. So going back to my more triangular look, if they are parallel to each other, the segments, and if they appear to be the same length, then we can jump to the conclusion that it is probably a translation. All right, now to identify the translation, then we have to create triangles from this segment or segments. Each one is a right triangle to identify the components, the left-right component and the up-down component that was used to create the translation. So let's show what that actually was here. And if we, just for verification, move these, and you see that these are all basically the same translation. And if we would do the triangle to any one of those segments, we could identify the up-down. Here it goes down 2.18, and it goes right 6.24. And of course that would change depending how we edit our shape. And we can also edit our here vector, which is causing this translation to take place. So now I have a movement upward of 2.15 and a movement to the left of 3.67. All right, so again, we started out by showing and connecting the segments from the point to the image points. As soon as you see that they appear to be parallel, then you focus on whether they appear to be the same length. If they are the same length and parallel, then it's a single translation. Okay, so here we have similar, black is the original ABC, images in red, and we have to see if it is from an original to the image as a single translation, reflection, or rotation. So again, we identified the corresponding points and we show or connect the segments. Now, these do appear to be parallel, and in fact they are, but they're not the same length. All right, and so the next step in this procedure is to identify the midpoint of each one of those segments and ultimately the perpendicular bisector. So the perpendicular bisector of those, we see that the midpoints are all collinear and the perpendicular bisectors are the same overlapping line. And so now we know it's a reflection. All right. And so it's a reflection. So point B was to the reflection line at a right angle, and out the other side the exact same distance. This line was movable, the reflection line, so let me just move it to show you some variations. And of course we had our points A, B, and C were also movable. All right, here we have our third example, and we have again the black is the original ABC and the image is in red. And we can again, since this application GeoGebra creates dynamic situations, we can move things around if we want. All right, so first step, as we did when we discovered the translation and the reflection, was to create the segments. Now here, definitely the segments do not look parallel. All right, so there are the segments from each point to its corresponding image point. So now we do the same thing we did when we were looking for a reflection, though. We find the midpoints, and basically we're looking at the perpendicular bisector of each of these segments. Well, each of these perpendicular bisectors is a different line this time. But if you notice, they all intersect at a single point. That point where they intersect is the point of rotation. So if we want to identify the angle of rotation, basically we just have to set up an angle that goes from a point to the point of rotation back to the image point. So let's do that. So when we do that, we have kind of two things shown here. It's 108 degrees if we are rotating clockwise. It would be a rotation of 252 degrees if we were rotating counterclockwise. And so that is, something that you can go clockwise or counterclockwise. Next step would be to show that this is dynamic, and I'm going to show what our actual transformation was. There's the point of rotation, and that point of rotation is dynamic here. And I can also change my angle of rotation. There's one of 90 degrees clockwise and 270 degrees counterclockwise. So we started the same way. We look at the segments from each point to its corresponding point. At this point, since they're not parallel and of the same distance and length, we go to the perpendicular bisectors. And these perpendicular bisectors all intersected at a single point. That's your point of rotation. You can then calculate the angle of rotation by measuring or drawing it in and then measure. And this again was one of these dynamic things. So again, our definition of congruence was that a two-dimensional figure is congruent to another if the second can be obtained from the first by a sequence of rotations, reflections, and translations. All right, and we here only described it as if it occurred from a single transformation, translation, reflection, or rotation. Now remember, someone may have created it using a sequence, but if we can identify it as a single transformation, that's what we're doing in this exercise. All right, we're not going through the ones that you can't identify just from a single transformation of a translation, reflection, or rotation.